Hi, everyone. Welcome back to another interview with an amazing Sloan professor. Today, I am joined by Professor Vivek Farias, and he's going to tell us about his journey here to MIT. Would you like to introduce yourself to the audience and tell us about your path as a professor here?
Yeah, so it's great to be, being a part of this. I've been at MIT for 18, coming up, actually, I'm in my 18th year over here. I started here in 2007. I'm a professor in the operations group, and I'm also associated with the OR Center. More recently, MIT started something called our GenAI Impact Consortium. It's a center of MIT's GenAI work around campus, and I'm one of the faculty co-directors for that. The other faculty co-directors in CSAIL, which is the Computer Science and AI Lab. I think I've always enjoyed learning new things, and I've always enjoyed tinkering and building things, and stuff like that. I worked actually a bit while I was in graduate school. And so, through the lens of that work, that's kind of what I thought I'd continue doing. But weirdly enough, the content of that work, it got me exposed to, the academic career, because it turns out there's lots of academics involved in that world.
Did you study data science in undergrad? What was your
Not really.
thesis?
Yeah. So again, I never really knew what I wanted to do. So here's the funny thing. So when I applied to graduate school, just to give you a sense of my sort of indecision. So when I applied to graduate school, I applied to programs in applied physics, in applied math, in electrical engineering, in operations research, all over the place, right? And I ended up doing electrical engineering. I'd picked up all these research projects to work on, things that caught my fancy. And in kind of working on these things, I found my path. In fact, actually, what I ended up doing in graduate school. I ended up working on reinforcement learning. All my research was, and it continues to be on that topic, right? And how did I get involved in reinforcement learning, and how did I get involved in doing this? So I'm not necessarily a mathematical person or anything like this. So, and I'm going to date myself here. There used to be this thing called RoboCup, not cup, right? And it was like robotic soccer.
Yeah.
And so I wanted to get involved in RoboCup. And as I sort of started getting involved in RoboCup, I realized that a lot of the stuff that one needed to do over there pertained to planning, right? You're if you play soccer, you're not thinking about the first domino that falls. You're thinking about the 100th domino that falls, ideally, if you're good, right? And that got me down this path. And I very quickly realized there were so many things I didn't know. It's a very tenuous process, but ultimately, I think it boiled down to just doing what I like doing. That was kind of it.
That's so cool. I never knew that. From electrical engineering to RoboCup to...
The RoboCup was before electrical engineering, actually. Yeah.
To GenAI at MIT. Tell us about some of the research that you're doing with your PhD students.
So a few of the areas I'm particularly interested in. So I spoke about reinforcement learning, right? And one of the things I'm very interested in with respect to reinforcement learning today is kind of thinking about how, and so there's this broad problem called alignment, okay, which is how do you take large language models, which ChatGPT is a large language model, right? How do I take large language models and align those models with, our preferences as human beings? So this problem is called the alignment problem. And, as LLMs and agentic AI and things like that get more common, this alignment is going to get more and more and more and more important. Okay, imagine, right? Imagine you have your own agent that's making decisions on your behalf. Well, you want it to behave like you, right? And so these tasks are non-trivial. And when faced with training data from lots of different individuals, from a diversity of individuals, how do you kind of weight this? How do you think about this? These are non-trivial questions. So this is an important research area for me. There are also more foundational things that I'm very interested in, and these range from problems of continual learning. This is the problem of how do you kind of just train a neural network forever, right? And you can imagine that that's not a crazy thing to ask, right? I build a model, I want to continuously feed it data over time. Well, what happens when you do this? Turns out lots of crazy things. Another problem I've been thinking quite a bit about, again, relating to sort of generative AI. If you think about running generative AI, right? You're running a large language model, inferencing, as they call it, a large language model. This is a process that's fundamentally sequential. So I generate, like, you can colloquially think of it as I generate a word, then having generated that word, I generate the next word, and then having generated those, I generate the third word, and so on and so forth.
Yeah.
So this is fundamentally a sequential process. It takes a lot of time, it takes a lot of energy, blah, blah, blah. Can we make this faster? Are there fundamental limits to making this faster, right? And this is like, and there are so many tacks at this problem, right? Like I can think about making this faster by building cleverer hardware, right? I can think about making this faster by building cleverer models. And in fact, people are thinking about this. Like, do we really need LLMs the way they are, or can diffusion models be used? There's so many different approaches out there. I'm kind of focused more on, with that problem, I view it as being so fundamental. I'm curious about the limits of what we can do, right? So yes, we'll eventually build algorithms and approaches and so on and so forth. But I think what's merited over here is an understanding of like the fundamental information theoretic limits of doing this.
Wow. And if a student out there would like to do research with you, how would they go about becoming part of your research group?
One is to talk with me, write me an email or something like that, right? But no, so for instance, for the Masters in Analytics, the MBAn program, I've been very proud to be associated with, over the years, on average, I think 3 or 4 students every year. So I didn't really talk about this, but there's a large sort of applied element to kind of everything we work on, right? And the applied element actually allows for an easier ingress point, for students. There's something for them to do. They get momentum. They're not stuck on something super hard, and they can make progress. And so all of these things are associated with, like, very often I have like a ton of like very real, very applied projects. I'll give you an example of a real project, right? Like, so one thing we're working on right now is with this large consumer goods company. They're trying to kind of understand whether they can do a better job of understanding how their consumers respond to various things they may do. But doing this using generative AI, okay? So using generative AI maybe to make a guess at this. It's a fascinating problem, okay? It's very applied. It's something that's like, very natural for a student, for, a master's student that to get involved in. The only honestly, the only prerequisites for doing this are, one, just being intellectually curious, right? You have to be super intellectually curious. And then the other is like, a willing, bring something to the table, right? Like, so for instance, maybe like some of the algorithm design scares you, but you're a great hacker. Conversely, maybe you're not a great hacker, but like, you're a great, right? Like, so bring something to the table and be intellectually curious. That's really typically what's needed.
And could you talk about this certificate that you launched as well, the product management certificate?
So I enjoy teaching. I've been involved in teaching a lot of things, starting this coming year, I'll teach I've been teaching this class called Hands-on Deep Learning. The idea is to kind of get you up and running and proficient with, building complex generative models from the ground up. And that's a class that I co-developed with a colleague of mine, Ramakrishnan. And we started on this class in like a long time ago, okay? We started in 2020. And right, like we're nerds. We're kind of very excited about the space. But yeah, that's grown tremendously in popularity. I've enjoyed doing this. I continue to do it. Right now, outside of these classes, there are other classes I've taught and teach at MIT. So it's about 8 years ago now, I sort of saw a trend where students from the business school, as opposed to thinking about careers in finance or in consulting, they were increasingly thinking about building their own companies, going into careers in tech. And it sort of became important to understand, okay, well, what is the core education for a career in tech? And so we created this like product management curriculum, okay, starting with a class, and actually that was the first class, right? That has grown into a full-on curriculum and an associated certificate. It's called the product management certificate, where you take a class. There's over IAP, you work closely as sort of being shadowing a product manager at a company and this and that. So it's been very exciting, just given the limits on my physical abilities in terms of teaching. I handed that class, so I could focus on hands-on deep learning. I handed that class over to another colleague of mine, a couple of years ago, Charlie Fine. And so now Charlie Fine, manages that. It's very successful. It's very exciting. And of course, I'm in the operations group over here. I teach the core operations management. I used to teach the core operations management class, but still teach it over the summer to our Sloan fellows. These are folks that have kind of been in industry for a while, and they're coming back.
Well, great. Well, I hope you stay at MIT for another 18 minimum years. And
yeah, minimum. Yeah.
And thank you so much for your time today. We learned so much from you.
Thanks, Michelle. And thank you all.
Hi, everyone. Thank you for watching. If you like this video, check out our other videos in the series where I interview influential professors at MIT Sloan. If you would like to learn more about the Master Business Analytics program, we also have a playlist where you can see more videos about the admissions process, student life, and the program overall.